Hey guys, it's Mr. Gron coming to you from my garage. If you don't believe me, this is my garage door, and you can kind of take a look around. That is my garage. So no more bathroom videos. We'll be doing them from in here, I think, for the rest of the time that I'm out. So mom and baby are doing good, so that's good. So let's get through this one. Now, 3 examples today for today's lesson. We're in 7.3 day 2, which is solving for missing sides when we've got similar triangles. So our first example looks kind of like this. My drawing isn't like perfectly to scale, but here is the idea. We're going to set up some proportions here and use that to solve for our missing side. Now we're looking for BE with this first one. So that's our side from here to here. So maybe we throw an X right there. The way I like to think of these is this. I want to isolate the 2 triangles and then compare the sides from one triangle to the other that are like the corresponding ones. The one like the short to short, long to long, that sort of thing. So one thing I'll do is take a colored pencil or something and then just highlight one of them. In this case, this one is blue. Unless you're colorblind or the color doesn't come through real well on this. And then we got our other one over here is red. So within our blue one, I've got 2 side lengths that are given. This is my short side and this is my long side, 54. With the red one, then here's where students get a little bit confused. They see 54, 54, they want to say that those are both long sides. Actually in this one, it's the short side. And in this one, X is our long side. Now, should have said this right away, but these are both similar triangles, and I know that because these 2 angles are lines are parallel. So I've got vertical angles, I've got alternate interiors. We know they're similar by angle. So anyhow, now that I've established I've got a short and a long side for my blue triangle, a short and a long side for my large triangle, or for my bigger triangle, my red triangle, I want to set up my proportions and solve. I'm going to do short to short, which would be, for my short sides, would be 36 over 54. And then my long sides, and again I want to go, if I started blue on top, red on bottom, I want to do blue on top, red on bottom again for the long sides. So for my long sides, that'll be 54 was the blue, and not sure what the long one is, that's our X. Now a little bit of cross multiplication and we can solve this. 54 times 54 is 2916. No, I didn't just come up with that off the top of my head. I've got my key available. And 36x. Divide both sides by 36. And that gives us that x is equal to 81. Let's make a better 8 for the video, since this is going on YouTube. If I plugged 81 back into this, then those 2 ratios, that proportion would be true. They would both reduce to the same fraction. So that one's good. That's good. Now the next 2 are really very similar, but there's one little difference with them, and it ends up being like how many times you use X. So we'll see what that is. The first one is a little bit simpler, and then the second one's a little bit tougher. Especially since you guys don't have a nice color printed key where you can really see that lovely colored picture like I do. But you know what? I went to college to be a teacher, you guys didn't, so I get to use I get to have things a little bit nicer. Alright, so our second example, we've got triangle in a triangle, a little triangle section. And it's going to look kind of like this. And what we got, it's cut like that. I know that these 2 angles are congruent, that's given to me. So I know that these 2 are similar triangles because I have 2 congruent angles, and then because that's given to me. And then this would be a reflexive property because both triangles use that angle. Let's see, we've got, this is point R, S, T, V, and U. this side is 12, 8, 10. And it is asking for the length of RT equals what? In this one now, if you notice, R to T is that entire top side. I don't know what the distance is from S to T. I know what it is from R to S. So I'm going to throw my X there. Even though that's not what the problem's asking me, this is what I need to know in order to solve this problem. Now again, I'm going to divide this up into the two different triangles, the smaller one and the bigger one. Last one was a little bit more obvious because it was like a left triangle and a right triangle. This one, sometimes, you know, sometimes you guys don't quite recognize this. So our smaller triangle is going to be this little shaver over here. And that's going to have a long side of 10 and a short side of 8. Then our red triangle is going to be the big overall triangle, like this, where now our short side is 12, and then our long side isn't X, and that's another mistake that students make a lot with this one. It's actually 10 plus X, so this is kind of a throwback to about section 1, 2 from the first semester when we were doing segment addition. So our long side for the red is 10 plus X. A long side for a red. So now I've got enough info, I can start setting up my ratios. Again, I'll go short in the blue to short in the red, then long in the blue over long in the red. So for our short sides, we've got 8 over 12. And for our long sides, we've got 10 on the blue one, and then 10 plus X for the red one. So we've got to use a little more advanced algebra with this one. Cross multiply. I might throw some parentheses around that just because more students are going to recognize what to do next when I multiply 8 by 10 plus X. This becomes 8 times 10 plus X, and then 12 times 10, that's 120. First thing I'm going to do with this is distribute the 8 in. And that's 80 plus 8x equals 120. And now I'm just solving for x. Subtract 80 from both sides. We get 8x equals 40. Divide by 8. And x equals 5. Now, am I done yet? No, this doesn't answer the question quite yet because it's asking what is the distance from R to T. If x is equal to 5, then part of R is 10, or part of RT is 10, part of RT is 5, so RT equals 10 plus 5, which is 15, and that is our final solution. So make sure that you're reading the answer, or reading the question, so you're actually answering what the question is asking. All right, last one. Now this in a lot of ways is very similar to the previous example, except the placement of x makes the math like one step harder. Oops. My whiteboard's getting kind of sticky. It's a little cool in my garage. It's a heated garage, but I don't have it like room temperature. I think I just bumped the thermostat on my way out, and so it probably got it to about, it's probably in the 50s where I'm standing right now. So it's pretty comfortable, but you know, I probably wouldn't be out here in like shorts and a t-shirt. You maybe just heard my heater kick on right there. So anyhow, our last example, it's the house one, and our diagram looks like this. Now hopefully yours is printed like well enough that you can read everything in there because it's not a color print. If not, you got my answer key, which is a color print on Canvas. And this one looks kind of like this. We got an A, we got a B, and we got a C, and an F, and a G. This side is 17, this section is 6.5, and then the bottom section is 24. And we are looking for BF. Kind of all looking for our BFs, right? So I'm going to throw an X right there for BF. Now, like with the last one, we had to add at the end. This one we're just solving for X, but we're still going to have to use some similar algebra to the last one. So, all right, I think I got everything I need. Just past the 11-minute mark, so this is good. It's good. All right, my two triangles. Very similar to the last one. I've got a smaller triangle on top here, and then I've got a big triangle that uses like the whole diagram. Now, the way I drew it a little bit, off from what it looks like in yours, but I think the idea is that the bottom of the triangles would be the large sides, and then the short sides would be the side over here. So then on my red one, I've got the larger side, the base is 24, and then again, it's not 17 for this one. The entire side, the short side for the red one, is 17 plus X. Now I can set up my ratios and solve this bad boy. Short sides, that'll be X over 17 plus X. And then my long side, 6.5 over 24. Yeah, there's decimals in this one. Big deal. We've got calculators. We can figure it out. Okay, cross multiply. X times 24 is 24X. And then we've got, maybe throw some parentheses around there, 6.5 times 17 plus X. Distribute in the 6.5. Now we've got 24 plus X equals 6.5 times 17 is apparently 110.5 plus 6.5X. Now, last one, I didn't have X on both sides, but you've done these since Algebra 1, at least. Subtract 6.5X from both sides. And 24 minus 6.5, that's got to be 17.5x, right? Yes. Equals 110.5. Divide both of them by 17.5, and we get that x is equal to, if I round to the nearest hundredth, 6.31. And there's your answer. There you have it. Hopefully, got a little glare from the lights in here, so hopefully we can see that okay. If not, it's on the key. It's on the note key, so take a look at that. Tomorrow you'll be starting review. We'll see what that's like. I'll have something for you to do on Canvas, and just be good for the sub and kind of follow the lesson plan. Do the best you can. We'll review for 2 days when I'm not there, and then when we're back on Tuesday, we'll do like kind of a wrap-up day where it'll be a little bit of review. It'll really be me just kind of feeling out where you guys are, and then hopefully we'll quiz on this stuff on Wednesday on 7.1 through 7.3. So have a good week, guys, and I will see you Tuesday.